Welcome back to Speller Tutorial Services. Today we're going to talk about odd functions. We're going to figure out how to tell if a function is in fact odd. There are two methods in identifying odd functions. One method is visually, the other method is algebraically. It's important that we know how to do both methods because during an assessment you may be asked to tell using a graph if the function is even or odd, and other times you may be asked to show algebraically if a function is even or odd. We're going to start with this function here. F of x is equal to x to the fifth power plus 2x cubed. Going ahead and graph this in another application, so let's take a look at it. All right, here we have two functions drawn on the Cartesian coordinate plane. First, I drew the y equals x, which is this slanted line here. This line here is the axis. Is the line of symmetry on the origin. The other is the actual function that we're working with, x to the fifth power plus 2x cubed, and that's the one here that has the curve. A function is said to be odd if that function is symmetric with respect to the origin. Another way of looking at this is that if we were to rotate this graph by 180 degrees, it will look the same as it does now. So let's go ahead and take a look at that. First, I'm going to go ahead and rotate it one time, 90 degrees, and then I'm going to rotate it again another 90 degrees for a complete turn of 180 degrees. We see here that the graph looks just like it did when we started, where it's increasing as we go from left to right. And you see I marked the graph top and bottom, and we see that the top and bottom have been replaced, but the graph is in fact in the same orientation even though it is turned. Now let's take a look at the second method, which is algebraically, so return back to our scratch pad. Alright, to tell if a function is odd algebraically, that means that if we were to input a negative x, our output would be the original function negated. So it would look like so. F of negative x is equal to negative f of x. So let's go ahead and give this a try. I'm going to input a negative x everywhere I see x in this function above, and that gives me negative x to the fifth power plus 2 times quantity negative x to the third power. Whenever you take a negative quantity and raise it to an odd power, the outcome is going to remain negative. So here, the 5 is odd, so we're going to remain at negative x to the fifth power. On the other side here, I have 2, and I'm multiplying that by negative x raised to the third power. We see that the 3 is an odd power, the negative x is a negative quantity, so that there is going to, again, give us a negative output. So here, inputting negative x, our output is negative x to the fifth power minus 2x cubed. Now let's go and negate the entire function. By doing so, I'm just going to place a negative on the outside of the function, and then I'm going to go ahead and distribute that negative throughout the function. All right, negative times x to the fifth is negative x to the fifth, and negative times a positive 2x cubed is negative 2x cubed. And we see here that the results from f of negative x is the same as the results of negative f of x. So we can in fact say that this function is odd. That concludes this video. I want to thank you for tuning in to Speller Tutorial Services. Please take a look at our Facebook page and also subscribe to our YouTube page. Thanks again for watching.